This is Greg Troutline with Maritime Reporter TV, and we're very pleased to be joined today by Chris Wiernicki, the CEO of ABS, to discuss MultiPhysics simulation as a broader part of shipping's decarbonization strategy. Chris, first and foremost, I truly thank you for joining us today, and neither yourself nor ABS needs an introduction to this audience, so we'll dive right in. To set the stage, the maritime industry faces decarbonization mandates for which today there is not a solution. Can you put in perspective the challenge that this industry faces, to put in perspective with other technical challenges that you've seen during your career?
Oh, thanks, Greg. So let me tell you, it's a pretty exciting time. Our world is changing. There is no question. I mean, I'll talk a little bit about some of the changes and the challenges and kind of the shapers that we're all dealing with. But you know, in real simple terms, we're no longer living in kind of what I call a linear, prescriptive, almost what I'd say component-based world. It is multidimensional, it's dynamic, it's system-based. We've seen this 4 or 5 years ago as we started to look at trying to understand, you know, the complexity around cyber-enabled physical systems. Now we're beginning to see this now in terms of decarbonization. But to provide a little bit of color, because I actually believe we're going to see more innovation probably in the next 10 years than we probably saw in the last century going forward. And it's not by accident, because I believe there are certain things that are kind of at play here. I mean, once you kind of get past what I call that, you know, kind of traditional change of market uncertainty and unpredictability, you're getting into the impact of regulations now with pretty legitimate, what I call shipping shapers. And we'll talk a little bit more about that relative to those outcomes that drive our decarbonization journey. But then on top of that, you've got digitization. You've got new technologies coming in at speeds faster than we've seen them. And probably even more importantly, the rate of change of these technologies are pretty significant. It's going to really, you know, it's causing us all to really begin to understand and really figure out what all that means. And of course, you know, in the last 18 months, you know, we're living this right now in ground zero. You've got COVID. And I will tell you, COVID, as much as we talk about it being a disruptor, it's been in many ways kind of an accelerator and a catalyst for some of this change. You get to kind of the challenges that are coming out of that. We mentioned regulations. Listen, you know, the big challenge now is low carbon shipping. It's introduced a new language of shipping. Our new language of shipping now is CO2 emissions per ton mile. And it also is introducing a dynamic that the solution is not a single solution. There's not a silver bullet. It is going to be multiple pathways, whether it's multiple fuel pathways. I'll talk a little bit about this, multiple technologies, combinations of fuels, technologies, and vessel performance. It's going to require essentially a hybrid solution. And of course, with that comes a hybrid mindset. And then, of course, like we talked about, is that backdrop of digitization. You know, digitization is going to be a little bit like a sixth sense relative to as we kind of handle decarbonization. It's clearly going to be a value opportunity, but the speed and scope of the digitization is going to be interesting to see how it moves forward. And then, of course, for us at ABS, what is really kind of in our wheelhouse that we are watching and kind of what we're built for is just making sure we understand those unintended safety consequences that are going to come from the change that we're talking about. And you know, that's a big deal in terms of identifying and coming up with solutions to minimize safety risk, because safety will be a boundary condition, I think, on our journey to decarbonization to meet the 2030 and 2050 targets. So when you look at the complexity and you look at the significant increase of system interconnectivity, you know, you begin to ask yourself, how am I going to really understand and begin to rationalize what is going on? And of course, this is where simulation comes in. It's an engineering technology that essentially allows us to visualize the interconnectivity of various cyber-enabled physical systems. And it's going to be really important now, because a lot of things that we're going to be doing as we move to 2050, that story hasn't been written yet. And so we're going to be able to need to visually simulate, understand what is going on. We learned about the science of the automotive and the aerospace industry taught us the science of simulation. What we want to do right now in the maritime sector is really begin to apply that. And I'll give you a great example. When you look at when we do a simulation, for example, to evaluate hull forms, let's say that optimize drag. But when you take that whole simulation and you combine it with an engine fuel consumption simulation, and then you combine that, let's say, with a power limitation simulation and a weather planning and seakeeping model, it becomes a multi-physics model. It begins to allow us to understand what are those variables that we need to use. But I'll tell you, Greg, more importantly, as the industry looks to where we are now and relative to future proofing, it allows us to look at the impact of electrification, for example, on an alternate fuel. It allows us to look at the impact of batteries, looking at the impact of certain decisions made on voyage performance relative to hull resistance, relative to alternate fuels. So this is a technology that really allows us to, with confidence, digitally touch kind of where things are, and then it allows us to essentially begin to kind of shape a framework and pathways going forward.
What specifically is multi-physics simulation?
So multi-physics simulation, I guess specifically, is the ability to simulate reality, okay? It is the ability to essentially model various systems and understand kind of their inoperability. It is different than a digital twin. That's a term that's being used. A digital twin simulation actually comes before a digital twin. Digital twin connects itself with reality through live data. Simulation is a representation of reality. What's important for simulation is that verification and validation piece going forward. We at ABS use essentially, commercial simulation technology, but what we do is we create libraries relative to the specific outcomes and the specific things that we are looking at.
Okay. Again, Chris, in your career, you can attest far better than I to the evolution of ship design. And we look today at a lot of the tools that are used to design ships. How does multi-physics simulation, is it materially different or better from the modern design programs that are already in use?
Well, listen, when I started my career many years ago, 30 years ago, we used to do a lot of structural finite element modeling, if you remember that. But multi-physics simulation is really not about one kind of model of one system. Its strength is the ability to bring in many simulations and work together. I'll give you a great example. Just take your cell phone. Okay, there's a lot of multi-physics going on there between the touching between the battery, the power, the connectivity relative to the signals and the actual touching of the screens. There's a lot of physical activity going on there in that particular case. And when you look at some of the challenges that we have, it's not, nothing is done in isolation. Success now, it's a team sport. When you look at and I'll get back to decarbonization, Greg, when you look at where we are and you look at where we have to go, what you're going to quickly see is that, to meet the 2030 challenges of CO2 reduction, you can kind of get there. You know, we're benchmarking the vessels right now. We're figuring out where their energy efficiency indices are. Surprisingly, a lot of vessels have to, you know, aren't making it. They have to basically they're gonna require, you know, engine power limitation reductions and, you know, some possible retrofits for energy efficiency devices. But in general, you can kind of get to 2030. And there are some scenarios, ABS has done some to kind of get us there. But to get from 2030 to 2050, boy, I tell you, that story's not been written, okay? And as we try to break it down, what we found is, aside from just understanding kind of different alternate fuel pathways, you know, LNG, for example, a light gas pathway, LNG to hydrogen, or LPG and alcohol to ammonia, or middle swim lane of biodiesels, which is considered a drop-in fuel. You know, all of a sudden, these fuels are no longer static; they're dynamic fuels. You know, you need to be able to understand, you know, that what's going on in that combustion cycle. But then you got to start looking at going forward. You know, what about future-proofing these? You know, you build an LNG vessel today. I mean, here's a great example of simulation. We have a great project. We're building a LNG dual fuel vessel today. Okay, we benchmark it. We know where it is with its carbon intensity trajectory. But you know, when it gets to a certain point, you're going to need to future-proof it. You got to figure out what to future-proof it with. What else are you going to need to do? And we have a project actually right now with an engine manufacturer, with a shipyard, and ABS is working through its the fuel consumption calculations. And we're looking at a lot of what-if scenarios. And some of these what-if scenarios, Greg, are some of these technologies, you know, haven't been commercialized yet. They're not even scalable. So, but we're trying to understand, because you're going to need to do something relative to, in this case, looking at batteries or electrification concepts like fuel cells. And so we're able to simulate this. That simulation model will go with the vessel. We'll be able to verify and validate it over time. And we have the ability to efficiently model different scenarios to be able to help us understand kind of where we are.
So Chris, I'm sure there are many challenges, but what do you see as the chief technical challenge today to integrate multiple engineering strands with 3D tools to turn a design into an active digital model?
I think I'll go back to validation and verification. You've got to have that. And that's going to, again, require a lot of joint effort. I mean, we're doing this with, you know, with a lot of industry partners. But I think the real challenge here is that continued validation and verification to kind of continue to make sure you take that zip code that you start with and you continue to kind of shrink it going forward, because that's what's going to give you the confidence to help you understand kind of what are those big blocks that need to be moved, what are those big things that are really going to make a difference going forward. Because one thing I didn't mention, in this new world, I am pretty convinced going forward that the chief technology officer and the chief financial officer are going to be sitting next to each other in a boardroom, really trying to assess the commercial risk of a developing technology, more so now than ever before. And so you've got to have something that you can fall back on to be able to justify that decision. We've seen it's, you know, what it's done relative to even becoming a predictive tool, especially in the area of predictive condition-based maintenance. But again, it's that ability to visualize a multitude of complex interconnected systems, to be able to begin to then rationalize and apply engineering experience and judgment to decide, you know, where you're going to get the biggest bang for your buck.
I know that we're still in the formative stage, but can you discuss the tangible benefits of MultiPhysics simulations that you see for ship designers, shipbuilders, and ship owners using the metrics of your choice?
Sure. Listen, I think at the end of the day, it's all about managing risk effectively and efficiently. you can really begin to, rather than physically testing everything, you're able to kind of almost really begin to form kind of that ultimate testing envelope. But I think at the end of the day, especially when you're talking about technologies that have not yet even been developed, or scalable, that maybe they've been developed, but they're not scalable yet. What simulation does, it gives you a very, very cost-effective way to begin to understand kind of where you should be focusing your priorities. In the case of ABS, it is going to be all about helping us understand where are those unintended safety consequences. It's no longer going to be kind of what I call component by component, everything is equally weighed. It's going to be a little different now. Simulation gives you that framework to be able to do that. And let me kind of take this a little step further, because I talked a little bit about the importance of people in this. As we talk a lot about kind of where we're going from a technology point of view and everything like that, simulation is going to be a wonderful training tool, relative to providing, whether it's shoreside or whether it's the crew on the vessel, an ability to really understand kind of what is going on, be able to respond. Because our biggest challenges, and we talk a lot about in the decarbonization, in our decarbonization topics and the challenges. We talk a lot again about technology, but the big challenge is we tend to sometimes think our seafarers, or we tend to see them in 20th century eyes, yet we're giving them 21st century responsibilities. And so training is going to be very, very important going forward. And it's an ability to recognize the pace and change of technology, to look at continuous training, blended training, where you're not going to be able to physically see things. You're going to be able to have to simulate them to help understand. So, kind of another piece we didn't touch is the importance of simulation as you develop your next generation training programs to handle, the journey to zero carbon.
Chris, again, I appreciate your time. I have only a couple more questions, and the next one is the really good one, because how specifically do you see multi-physics simulation fitting into the decarbonization discussion?
Well, like I've said, when you look at the decarbonization, the potential solutions to achieve our decarbonization outcomes, they kind of, when you break it down, they fall into three buckets, and there's enough complexity within each one of the buckets. But when you start trying to look at the interconnectivity between the three buckets, you really need to begin to kind of visually understand what's going on. You've got and of course we've talked about it. You've got the pathway of alternate, the various alternate fuel pathways. That in itself is a systems engineering issue, depending on where you start and kind of which way you're going ultimately, relative to if you're getting to some sort of zero carbon fuel. But then you have the issues of other technologies, in the case of future proofing, it's electrification, carbon capture. We're doing a lot of work right now in biomimicry, looking at next generation energy efficiency devices related to hole resistance. Part of the problem on decarbonization is we talk a lot about kind of the combustion cycle, but the real problem, quite frankly, has to be extended. It's from the what I call well to the wake, whether it's a green fuel or a blue fuel. You have to understand, not only the CO2 footprint along the way, but just exactly how that kind of works. So you have the ability, and we do have the ability now to simulate, whether it's something relative specific or something relatively broad. Simulation, Greg, allows us to do our techno-economic studies relative to guiding our clients relative to investment decisions and scalability and so forth. And then the last bucket is importance of vessel performance, vessel optimization. You hear terms like just-in-time shipping, you hear terms about speed optimization, things like that. Digital technology comes into play. But, like I said, when you start marrying different systems, a fuel consumption system with a power limitation, with looking at just a hull resistance and drag, and then you look at weather routing and you look at other things, you get a huge profile. And you have now an opportunity to take the right decision for that specific set of assumptions. That's going to be very important because, like I said, the story, kind of the last 20 years of this story, getting to 2050, has not been written, and it's going to take. You have to start it now, and you kind of have to know where you're going, because I think Yogi Berra said, if you don't know where you're going, any road will take you there. So what we're really looking is to find a little bit more clarity, a little bit more definition to some of these swim lanes, so we can, I think, as an industry collectively, begin to really focus in on making the right investment decisions, okay, going forward. Because like I said, a lot of this story is not on the ship. It's actually going to be at the port. It's going to be at bunkering. It's going to, you can work your way back. And all that needs to be understood. And, we can't build that. The infrastructure is not there. It's too, there's a lot of uncertainty. You've got to begin to frame this. And this is, I think, in simulation's sweet spot, to be honest with you.
I have one more question. Specifically, where are we today? And by that, I mean, what is going on at ABS to make multi-physics simulation a reality?
Well, we have made a lot of investments. We're actually setting up our simulation center of excellence in Singapore. We're working very closely with the Singaporean government to create a pretty significant kind of center of what I call muscle from that point of view. And of course, we will have simulation centers, geographically across the ABS operation. Just about every one of our joint development projects, Greg, whether it's with a yard and an owner or a yard owner equipment manufacturer, has some level of simulation embedded in it, because it allows us to begin to quantify risk, understand risk, really begin to kind of help us pull this together, because ultimately that's the type of stuff that gets embedded into our rules, and that's very important. And then on the learning side, we are betting on simulation going forward. So if you kind of roll all those together, I guess what I'm telling you is ABS is betting a lot on simulation as that kind of digital sixth sense that's going to help us, continue to do what we do well, which is really, we're a safety-centric organization. Now more than ever, we're being called on by industry to be that go-to trusted advisor. We've got to extend our line of sight in order to do that. Simulation gives us that capability. It even allows us, to some extent, with our data analytics capability, allows us to even predict things going forward. So it allows us to kind of begin to extend our classification role to something even further, more like an integrator, an assessor, a predictor, kind of that go-to solutions advisor to help the industry going forward. So we're betting a lot on this.
Chris, as always, a pleasure to talk to you, and I look forward to talking to you and your team as this moves forward.
Stay safe and well. It is always a pleasure, Greg.